Good morning, folks. This is the second lecture of week 10. And here is what's on the agenda today. I have a block that is moving on a track, and it's going to be oscillating in a portion of the track. So you really have to write a few lines of C code in order to do that. Okay. And then we'll worry about the two block racing later on. So here's the situation. You have this track and have a block sitting on it and it's moving. It's the first problem that we did in the class, but in that situation we specified, for example, the acceleration of the block. And once you have the acceleration, you basically have the position as a function of time, and it was a constant acceleration. In fact, it was a parabolic, expression that we could put it in just as a single formula. So we go to the length-driven command and add a formula to it, and the formula was basically the 1/2 of the acceleration that was given times time squared, nothing else. Here, the situation is different. For example, if we know that if the time is less than 2 seconds, it's going at a constant speed, then then at 2 seconds at that location starts oscillating twice, and then after 4 seconds, it's going to go at a constant speed again. So there's no way you can actually put this thing as a single formula. You have to write it as a rule and with a few lines of code to make sure that this happens. Now, what I'm going to do is I'm going to assume that the length of the track is about 16 inches, and the block is, or maybe 15 inches. The block being 1 by 1. Okay, so after 10 seconds, it will actually should end up at the end of the track. Okay. Now, one other thing I want to tell you is that when you these are the positions, by the way. When you look at this expression, so two uh, in in 2 seconds, you have two oscillation of the sine, and the two oscillation of the sine. That means that the period of that sine curve is actually one 1 second. 1 second. So in 1 second, it does one full oscillation, and that is the period. So based on that, the frequency is going to be 2 pi in 1 second, but everything has to be written in degrees because my default units for angle is degrees. So I have to 2 pi, which is the frequency of this, per second. I have to write it at 360 degrees per second. That's the only thing that you have to watch out. And notice that these all have the shift in the uh, in the uh, the time. In other words, this, by the way, is a mistake. It should be F4S, 4S, not 4. With the 4, you get a mistake because there's no way you can add second into something that doesn't have unit. This should be 4S, just like this is 2S. Okay. All right. Good. So let's go ahead and start our. CATIA program. Immediately, I will save this thing. What is that? File, save management, save as, desktop, new folder, week 10, lecture 2. Okay. Okay, let me insert the track first. So insert a new part in there. I'm going to call it the track. Right click properties, track, and track. Okay, let's go make it. So there we are. Double click on that vertical plane. I will sketch I'll sketch a rectangle that is 1 inch wide. That size is totally irrelevant. 1. And I'll make this thing maybe 0.2. Okay, so that's going to be my track exit. And I will pad it by 15 inches. Good. Then I'm going to insert my block. So insert a new part in there, and I'm going to call this thing block. Block and block. Okay, let's make it. So on that same vertical plane, I will sketch a rectangle that is 1 by 1 by 1. So let me make this thing 1 inch like that. Actually, you know what? I'm going to make this thing 0.5. Just to put some exit and pad it by 1 inch. The reason I changed this 0.5, I don't want you to get the impression that this width has to be the same as that in order for it to have a prismatic joint. That is not the case. Okay, good. Let's anchor the base or the track right there. And I'm going to bring this thing and put it down there. So coincidence between, why don't we do it like that? This edge and that edge, that'll bring it down. And coincidence between this face and that face, and that will make it, the two of these make it together prismatic joint. Okay, that's pretty good. Now, we're done here. So let's save everything. So we're going to go to digital markup, DMU kinematics, get the magic wand out, a new mechanism. It's going to be auto create. We say OK. And there should be a single prismatic joint there. Yeah, it's right there. And the degree of freedom is 1. That's because the position of this block along that track can be determined by a single number, the distance that it has traveled, basically. So I'm going to double click on that prismatic, make it length driven. Now, notice that there is a blue arrow here, which means that the block is going to move that way. I don't want it to go that way, so I click on that so that it goes to the left. Okay, and these numbers basically give you the range of motion of the block, but since we're going to put some physics into it, and the physics only takes it to 14 inches, it doesn't matter. So it doesn't matter what those things are. Okay, good. So to write those formulas, the way I've shown you, there are other ways. So you go to Start, go to KnowledgeWare and Knowledge Advisor, and this thing pops up. The Knowledge Advisor looks like somebody's graduation hat, by the way, right there. Okay, so there is it. There it is. In this toolbar, which is called Reactive Features. I have no clue why it's called Reactive Features, but one of the things that we can do is write a program right there. See that? It says a rule. You click on it. You can give it a name. This is just a name, rule 1, rule 2, rule 3, my rule, whatever, and the date, etc. And we say OK, and we are ready to go. OK, so let me remind you that if you want to filter this out, this is all the stuff that is used in the creation of this assembly. But if you want to filter out only the stuff that we need for the mechanism, just click on this. There's only 2 things, time and the length. The length is that command that we made length driven. Okay, now the keywords for the programming is also here. If, else, else if, dot, 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 dot. So we know that these are very easy. Let's go back there. So first thing is the breakpoints are as follows. If time is less than 2, 6 inches over 2 seconds. 6 inches over 2 seconds is the velocity. Okay, so we put down here if the kinematic, if the time, this is the variable for the time, formal name for the time, is less than 2, don't forget to say 2s. Okay, and then if that is the case, then the length is equal to the speed, which was 6 inches divided by 2s. Can I write it as 3 inches over 1s? Yes. Can I write it as 6 inches underscore 2s? No, because we already know these things. Times a time, right there. Let's make sure that it is 6 inches over 2-second period. Okay. And then the other breakpoint is the breakpoint 4. Else, if time is less than 4 seconds, so else if you don't remember, keyword else if, back to parameter, time. I put the cursor there, left click twice. Okay, fast. Minus, if time is less than 4 seconds, the length is equal to, now you got to be careful here because it starts at the height of 6. So 6 plus, okay? Another way to look at it is 6 plus 6 inches, don't forget, 6 in plus. Now the amplitude of the oscillation of this is peak to peak is 12, so the amplitude is actually 6 inches up, 6 inches down. So you have to take that into account, plus 6 in times sine of the parentheses, okay? Now, remember, you have to give it the shift in the time, and I want to remind you how you write this thing down, is going to be t minus 2s. This is the shift. Shift is over here. And then don't forget to put this 360 degrees over one thing. So it's going to be parentheses, another parentheses, obviously, another parentheses, the time minus 2s, close the parentheses, multiply by that thing that I have, 300 conversion, 360 DEG divided by 1 second. And make sure you close the parentheses, okay? How many parentheses do we have? I think I need one more. You know what? I think I need one more, maybe not. So this takes care of that. Yeah, I think it's okay. If you are short of these or you put too many, it's going to give you a syntax error, and you have to go clean it up. Now, finally, this is going to be it. So it starts at 6 inches and then it builds up. So it's going to be 6 inches over what is that? Sorry, 6 seconds. In 6 seconds, it's going to make how much is that? 8 inches. From here to here is 8 inches over 6 seconds, right? 8 inches over 6 seconds. And there's a mistake here. This should be 4s. So let's go ahead and do that. Wait a minute. It is, yeah, that's correct. Yeah, that was a mistake. It should be 4s. Okay. So let's go ahead. Else we don't need any condition on time anymore because we know that it's past 4 seconds. So the length is equal to 6 inches plus, what is that thing? We said that it's 8 inches in 6 seconds times parentheses time minus 4s. Remember, I forgot the s? Okay. Hopefully, all the parentheses are matching. There is no typos, etc. And we say okay. Yeah, no problem. Once again, if you go here and take something out, for example, let me go back there. Let me just go back there. Put an extra parentheses here. I say okay. It's going to come back. There is a problem. Obviously, no. Oh, what is that? Take away that. Take away that parentheses, we say okay. Good. And this is deactivated here. Make sure it is active. Right click, it got deactivated as soon as I got that error message to activate. There, it comes back. Okay, good. And now we're going to go and do simulation with laws. Now, remember, I want to check whether I made a mistake or not. So what I'm going to do is I'm going to create a sensor first at this location, a ball rolling down a ramp. So that location, what is that? Reference product is the base, okay, and the point is that point, and we say okay. So something has been created here. Now I'm going to go simulation with laws. We want to do it over 10 seconds. If not, then we go and change it here, but we do want to and activate. Now, if you just select the joint, it will give you, unless you made a mistake, it should give you that graph. If you want velocities and things like that of that point, then that's a different story. And in fact, I'm going to do that later. First, I want to make sure that I do get what I asked for, or what I programmed actually. So move down here. All I did was to activate the joint length command. And then we play it. Let's see out of the way. Remember that oscillation? Comes back here. And then we go there, graph it, and there we are. So that is okay. Now, if you, by the way, let me change the number of steps here. Let me change the number of steps to fewer to see what happens. You see that? So I'm going to clear the history, by the way. Clear the history, because otherwise you get graph on top of graph. You see, it becomes kind of jagged. It doesn't even show that oscillation. Okay, let's try it again. Rewind. Rewind. Let's take more steps. For example, 40. Okay, let's clear the history. Play it. And graph it. You see? So that thing has to do with how jagged your curve is going to be. Rewind. If you go back to 80, clear the history, and play it, you can see a nicer. Actually, let's try to do it even, see if we can make it even smaller. Rewind. Clear the history. For that, let me put 200. Okay, play it. Okay, we're going to play it in just a second. When it finishes, it's going to be very nice and smooth. I think I didn't clear the history. So let me go back here one more time. Rewind, clear the history, play, and graph. There. It's smoother than what I originally had. Now, if you want to plot the velocity of that point, that's a different story. First of all, rewind, clear the history. On this selection, let's go and get the, that will be x linear speed, for example. Notice that it's going to be positive and negative. It will be positive and negative unless I ask for magnitude of it. So x vertex, okay, not x vertex, that's position. What is that? By the way, if I had done x vertex, I would have got exactly the same graph as doing the joint command. So x linear speed, and did I clear the history? I think I did. Yep, there's nothing there. So play it. So obviously there's going to be zero, a constant, a constant velocity in the first portion, a constant velocity in the second portion, and of course there's going to be cosine type expression in the second, in the middle part. Yeah. Oh, you know what? Because I'm asking for both plots. Go back there. Rewind. Clear the history. Don't ask for the other one, which was this guy. I don't want any. See that? This was the joint command. Say no, play, only get X component of the velocity, not the joint command. The join command, not the joint, the join command. And there we are. So constant velocity here, constant velocity there, and then your cosine term popping up like that. Good. So that takes care of this problem. Rewind, close, save in case I ever need this problem. Let's go to our next problem. Oh, by the way, the code is written here for you. Okay, this is exactly what I typed in. Okay, good. Now I'm going to do this problem where there's two blocks which are kind of racing against each other according to these laws. And now notice that the breakpoint for these laws are different. Okay, that being the case, it's a good idea to write each one of these as a single rule. A rule for the green block, a rule for the blue block, and then use it. Okay, so let's go ahead and try it. We go here, get rid of this. So start with the product file. Okay, immediately I save this thing. So file, save management, save as, uh, desktop, new folder, and I will put here blocks racing. Okay. So insert a new part in there. Let's do that at the track, right? Properties. We're going to do that as the track. Further down, track. Okay. Make it. Double click on that plane, that vertical plane. I'm going to sketch this. This is going to be my track. Exit. By the way, since this is about 20 inches, I'm going to make that thing 20 inches long, okay? Just so that it looks nicer. That's all. 20. There we are. Okay. So we go all the way there, the top. Let's go to the assembly design here. So insert the blue block. Insert new part in there. No. And I'm going to call this thing right-click blue block. Blue block. And blue block. Okay. Let's make it. Double click on the blue block. Let's see now. Although it doesn't matter. Okay, I'll do the blue block on that side. So on that plane, I will sketch. Okay, so let's see now. Normal view. Oops, normal view. Yeah, something like this. I'll clean it up. Okay, so let me see. Yeah, that's good. Exit. You know what? Just so that they look the same size, I will make this thing 0.3. Okay, exit. And I'll make this thing, I don't know, maybe about half an inch, 0.5. Yeah, okay. Why don't I change the color of it too? Right click, properties, make it blue. Very good. So we go all the way to the top, insert, insert, new part in there. This is going to be the green block. Right click, properties, green block, green block, green block. Let's make it. Double click on that same plane. I will sketch. Okay, another rectangle like that. And just so that they look the same size, I made this thing 0.3. 0.3. Okay, so what is the size of this? I don't know, but the way to make it match exactly, so we can do that. The control. Coincident. Don't have to be. This guy control that. Also coincident. Oops, where is it? Okay, good. Exit. Padded, I think we did 0.5. Okay, and change the color here. You put the cursor on this line. Right click properties. And for the graphics, we use that's green. Green. Okay, good. So you go all the way to the top, all the way to the top, and save everything. And now we start creating our joints. So let's see. Let's anchor the track. Okay. And I'm going to make a coincidence between this edge and that edge, and coincidence between this face and that face, or you can do the bottom face of the two, and update is going to bring it down. Repeat it on the side, coincidence between this edge and that edge. I think I did it right. Coincidence between this face and that face, and update. Yep, that's good. That's good. Okay. So that's pretty much it. So we're going to get two prismatic joints. So we go to digital markup, DMU kinematics, and get the magic wand out. New mechanism, auto create. So if we didn't make any mistake, there will be two, degree of freedom will be, oh, I forgot to say auto create. Let's try it again. New mechanism. Actually, you know what? Let's do the following. Let me delete this. Try it again. Magic wand, new mechanism, mechanism 1, auto create, say OK. Degree of freedom is 2 and 2 prismatic joint. Now both of these will need to be length driven because you want to put some rules into it, right? So double click on this, you make this thing length driven, but I want to go to in the other direction. Remember there's a blue arrow there, you flip it, and you want to make this thing length driven, and once again flip the arrow. Okay. Needless to say that this can be animated now. But notice that if you go and click on the simulation with command, notice that there's two bars, one for this one, you see that? You see that? Reset. And one for the other one. But remember, I can always make a cartoon without any physics. So for example, even though there is two sliding bar here, I can go and say simulation, mechanism number one, say, okay, this is not what I want to do, but I can cheat. So we go here, 20, okay? Remember this was 20 inches, okay? And enter. It's going to go to 20 inches. Try this one, 20, enter. This is going to go there. And then I say insert and then rewind and change this into anything but one. And I can play this thing continuously. This is a cartoon. And I could have done anything that I wanted with it. I could have taken this bar and drag it back and forth and then insert it. So this block would go back and forth, But anyway, I just want to tell you that it's easy to make good looking cartoon. The reason we don't ask you to generate video files and submit it as proof that you have actually done it is because, look, there's no physics here. But you can make it look like you have put physics into it so that things are moving. They're moving because you are dragging it, not based on laws of physics. We don't want any animation file. I think I mentioned once to you that we don't want these because the size of these animation files are big or these AVR file is big. We don't want it. That is really not the reason. The reason is that we don't know what you have done. Okay. Anyway, so let me delete this simulation. I don't want this. Delete this. Okay, good. So now we're going to put those physics, the laws into it. Incidentally, you all know how to hide stuff. These are all bothering me. So you can go to this plane and select it one by one and hide it. Or you can go to edit, search, here type plane. So all the planes I want it to be found and picked. Select it right there. Wait for it to come. Okay, there. And then I can hide them. Where's the hide? Right there. Instead of going, because if there is 200 planes to go through the tree and try to do it is no good. And I don't want these constraints either. So I'm going to put the cursor there, hide. It's a nice and clean thing. Okay. Now to put the physics, notice that there is no law here. You can see that yet. So we go to start. KnowledgeWare, very important tool, application, Knowledge Advisor. This thing pops up, and here is how you write your code. Remember, we did this thing in the earlier part of the lecture. So let me do this one for the blue one. So blue block. Blue block. Okay. Blue block. We say, okay, so we say, all right. Now here's what we have to do. We have to go back and forth between this, which one am I doing here? Am I doing the blue one? Yeah, blue one. Okay, so you have to go back and forth between this graph. So if time is less than 3, I don't want the block to move. If time is less than 3, I don't want the blue block to move. So we go here, we say if time, now you get the time information or the parameter associated with the mechanism. You click on this thing, here is the time. If the time is less than 3 seconds, hit enter. And which one do I want here? Oh, oops. Command 1. The question is, which one was command 1? Did I? Yeah, it must have been, yeah, the blue one must have been the command 1, this one, because I made these length driven in that order, so it must be blue one. So blue one is command 1. So it's there, equal to 0 inches. 0 inches. Do not forget to put 0 in there. Anyway, we can check these things, see whether we made a mistake or not. Else if time, now let's see now, time is less than 5 seconds, 5 seconds, enter, command equal to. Now, if you look at the speed here, it is 5 over 2 seconds or 2.5 inches per second. It's up to you how you want to type it. I'll write 5 over 2 so that I can see it. So 5 inches divided by 2 seconds times time. Okay. Else, if, okay, again, time is less than, now we go back here, the time is less than 9 seconds, 9 seconds, right? 9 seconds, 9 seconds, enter, command 1 equal to, now let's go back here. So that starts at the height of 5 plus, so it's going to be 5 inches plus, 5 inches plus, now what is that speed here? It's going to be, oops, this one. It's going to stay there. It's going to stay there. It's going to stay there. So it's just going to be 5 inches. Enter. Else, if time, let's go back here, is less than, oh, this last one we don't have to. It's going to be, it's going to be, we don't have to say else if, we just have to say else. Else, it's 5 inches plus this slope. So we don't have to say else if, it's just else. Else, let's take this thing out. Take this thing out. Command 1 equal to 5 inches plus, what is this? Let's go back here. And I'm going to trust that this number is right. So I'll write down 15 inches over 1s. Or I can put down here, yeah, it is 15 inches over 1s. This is 5, this is 20. 15 inches over 1s. So 15 inches, 15 inches divided by 1s, close, times, parentheses, time, minus, and that will be minus 9 seconds, yeah? 9 seconds. We should always check. For example, just hypothetically, if time is 9, 9 minus 9 is 0, so it's got 5 inches, and that is correct. If time is 10, so that's going to be 10 minus 9 is 1, 15 plus 5 is 20, and that is 20. That's correct. Hopefully we don't have a syntax error. We just say okay. Oh, there's something wrong here. Let's check it. Let's check it. So over there, else if time is less than 9 seconds, see, when I try to close this thing, it tells me that there's a syntax error, and you can see that. See that? EKSE. So right there, this should be else, not X. Else. Okay, say okay. No problem. Here's the blue law. And now we're going to go do another one for the green law. Green law. Green block. Okay. You say okay. And now we have to put in the information for this curve. So the breakpoints are the 2. If t is less than 2, 2.5 inches per second. So let's go here. If time Click on the mechanism. Here's your time. If time is less than 2 seconds, enter. This is command 2 now. Command 2 is for the green one. Is equal to, what was that? I can't remember. It was 2, the green one, right? 5 over 2, which is 2.5. Okay, so I'll write it like that. 5 inches divided by 2 seconds times time, else if time, else if, so else if time is less than 5 seconds, 5 seconds, and then here is going to be 5 inches, the green one is going to stay there actually, right? It's going to stay there, so it's going to be 5 inches. Yeah, so that's going to be 5 inches. This one equal to 5 inches. 5 inches. Else if time is less than, well, we don't need else if because it goes straight up. Okay, so we don't need else if, we just say else. So else. Okay, so if else command 2 equal to 5 inches, 5 inches. So that's going to be yeah, 5 inches plus, this is how many? 15 over 5 seconds, or 3 inches over a second. So I'm going to write it plus 15 inches divided by 5 seconds times parentheses time. Don't forget to put this shift in there though, minus 5s. And always check. For example, if the time is 10, 10 minus 5 is 5. 5 plus 5 is, the 10 minus 5 is 5. And then that kills at this denominator. So it's going to be 20. 5 plus 15. Okay, so I'm pretty sure this is okay. And hopefully there's no typos. Oh, there is a typo. What is that thing? Let's check that. Invalid structure, syntax. Okay, so let's check it. It's right there, obviously. Oh yeah. Oh, the forgot equal sign here. Equal. And says okay. Very good. Okay, so now let's go back to DMU. Okay, and then we use let's create a sensor. And it really doesn't matter which one. There is 2 joints here. It doesn't matter. So I'm going to create a sensor. So it's going to be what is that? The reference is that base and or the track, and the point is there. Now I don't need information about these 2. I need information about these 2 joints, but it looks like you will need one sensor to do that. And simulation with laws, you go there and then activate sensor. Notice that these are the 2 joints that I want to check their work, check my work against. So say yes and yes, these are both yeses. I don't need any information about the velocity of this point or anything. I just want to make sure that the positions of these 2 joints are exactly what I inputted. So just play it. This is the racing, remember? And then it's going to go fast. Yeah, very good. So graph it. These should be these graphs, and definitely they're not. One of them is not. So let's see which one is not. So the green one is okay, but the yellow one is not. The yellow one is not. The yellow one is not. The yellow one is actually that the yellow one is prismatic 1, which is command 1. So let's go ahead and find out where I made a mistake. So rewind, close it, close it, close it. Let's go to the blue one. I think it was the blue one that I made the mistake. Let's check it out. So it says if the time is less than 3 seconds, stay where you are. If time is less than 3 seconds, stay where you are. And then go with a speed of 2.5 inches. So it's going to be 2.5 inches times time minus 3 times time minus 3. Aha, right there, right there. It should be, this should be parentheses here. And minus 3 seconds. Minus 3 seconds, okay. And I think that may do it. So let's say okay. Let's say okay. All right, let's go ahead and do simulation with laws. Activate sensor. These are still on. So play it. Play it. Graph. And there we are. What you see here is what we put together. That is correct now. Okay, folks. So that takes care of this lecture. See you tomorrow.